Hello students, I am Krati Gupta. Today's topic will be polynomial addition using linked list. The content which we will be studying in today's lecture will be operation on polynomials, polynomial addition, algorithm for polynomial addition, program for polynomial addition. There will be a short assignment for you, then how we can perform the multiplication of polynomials. Okay, so first is the operation on polynomials. We have already studied in our previous lecture that there are different operations that are performed on polynomials. Some of the operations can be addition on polynomial, subtraction on polynomial, multiplication on of polynomials, differentiation, integration. Okay, so we will be starting the first operation, that is addition on polynomials. Now when we are having two polynomial equations, how we are performing the additions? We are adding the coefficient term of both the equation if the exponent of both the equation are same, and if the exponent part of the equation are not same, then the coefficient and exponent part of that particular term of that particular equation is added as it is in the resultant polynomial. Okay, so we take an example. We have two inputs. First number is the first equation 5x square plus 4x plus 2, and the second polynomial equation is 5x plus 5. X bar 0 means 1, so it will be 5. Now we want to perform the addition of these two polynomial equation. We will be scanning both the equation from left to right. Okay, now we have taken first term from the first equation, that is 5x square, and first term from the second equation, that is 5x. We compared the exponent part of both the terms. The first equation is having x square and the second equation is having x. So the exponent of both the equation are not same. If they are not same, then we will be checking for higher exponent part. As the first equation is having the higher exponent x square, so we will be taking 5x square, this first term of the first equation, as it is in our resultant polynomial 5x square, and then we will be moving to the next term of the first equation, the term which we are taking in our resultant polynomial. Whichever equation we are from which we are taking the term, then in that particular equation we are moving on the second term, that is 4x. Now we will be comparing 4x, this term, with the first term of the second equation 5x. The exponent part of both the equation is same, x and x. If the exponent of both the equation are same, then we will add the coefficient part of both the terms, 5 plus 4, that is 9, and we will use the same exponent, that is x power 1, and we will be moving to next term of both the equation. Next term of this particular equation, first term, that is 2x power 0, and next term of the second equation 5x power 0. As exponent part of both the equation are same, we will add the coefficient 5 plus 2, that is 7, and use the same exponent. Okay, we will be moving to the next term. There is no next term in the first equation. We will be moving in the next term of the second equation. There is no term in the second equation. So the final result of addition of two polynomial equation will be 5x square plus 9x plus 7. Okay, this way we are performing the polynomial addition of two polynomial equation. Now if we are storing our polynomial equation in the form of linked list, what the structure of a node in which we are storing this polynomial equation is, we are having the coefficient part, then we are having the exponent part, and in the next field we are having the address of the next node. Okay, and we have stored the value of exponent in the decreasing order. Okay, so the highest exponent value is always stored in the first node, and the lowest exponent value is always stored in the last node. And how we can identify that a particular node is the last node? If the next part of that particular node is null. Okay, so we have stored both the polynomial equation, the example which we have taken, 5x squared. So 5 was the coefficient and 2 was the exponent part. Then 4x, 4 is the coefficient and 1 is the exponent part. Then plus 2. So 2 is the coefficient and x power 0. So 0 is the exponent part, and this was the last term. So we have stored the null in the next field. Okay, and 5x plus 5. So 5 is the coefficient, 1 is the exponent. Then over here 5. So 5 is the coefficient and 0 is the exponent. Last is null. Now we will be comparing the first term of the first polynomial equation with the first term of the second polynomial equation. We have compared the exponent part as the exponent parts are not equal. If they are not equal, then we will be comparing which is the highest exponent part. Whichever term is having the highest exponent value will be taken as it is in the resultant polynomial. That particular node will be taken as it is. So first term of the first polynomial equation is having the highest exponent value 2 as compared to the first term of the second polynomial equation. So we have taken this particular node as it is in a resultant list. Then we have moved in the next term of that particular list. So next is 4x. Now we will be comparing the second term of the first polynomial equation with the first term of the second polynomial equation. The exponent part of both the terms are same. So we will add the coefficient part of both the expression, both the terms. 5 plus 4, we have taken 9 as a coefficient part. Exponent is same as it is, we have taken exponent of any value because both are same. And then we will be switching to next term of both the equation. So we are in the third term of the first polynomial equation and second term of the second polynomial equation. We compare the exponent value for both the terms. The exponent value for both the terms are equal. So if the exponent value of both the terms are equal, we will be adding the coefficient value for both the terms. 5 plus 2, 7, and we have taken one of the exponent value as both are same, 0. Now we will be moving to the next term of the first polynomial equation, that is null. That means no node exists. Then we will be switching to the next term of the second polynomial equation, that is also null. That means we have reached end of the node in both the polynomial equation. In that case, this is the last node in the resultant polynomial, so we will store null in the linked part. Okay, so this way we are adding two polynomial equations in a linked list. Achha, one more case, that is if in any case one of the list get over. Suppose the term is only 9x power 3 in the first linked list, and this is our this particular list is our second linked list. So if we will be comparing 9x power 3 with this particular exponent part, that list is having highest exponent value. Exponent values are not same, and this that particular list will be having highest exponent value. So that particular node is copied as it is in a resultant polynomial. Now next term of that particular list will be null. That means no list exists after that. So the second list will be copied as it is in the resultant polynomial. If any of the list is over and second list is having certain data, certain nodes, then that particular node will be copied as it is in the resultant polynomial. Okay, so on the basis of these conditions, we have designed an algorithm for the polynomial equation. We will be repeating a step 3 till step 3 if there are terms in both the polynomial that are to be processed. If there are terms in both the polynomials, then we will be performing certain steps. Okay, that steps are, first is obtain the value for each term. For each term means for the first term for the first polynomial equation and the first term for the second polynomial equation. We have obtained the values for both the terms. Now what we were doing in the next step, we were comparing the exponent value of for both the terms of the polynomial equation. So we are doing the same. If the exponent power of the both the terms of the corresponding polynomials are equal, then the coefficient of both the terms are added and place the sum in the coefficient term of the resultant polynomial. We were doing the same thing. We were comparing the exponent value for both the terms, and if the value of exponent are same, then we were adding the coefficient value for both the terms and placing the sum in the coefficient term of a resultant polynomial. And we were also copying the exponent term in the exponent term of a resultant polynomial. We can copy from any of the term as both the exponent value are same. But if this condition is false, if the exponent value of both the terms are not equal, in that case we were checking the exponent value of first polynomial. Is this polynomial exponent value of this particular polynomial term is greater than the second exponent term of the second polynomial? If the first exponent value of the first polynomial equation first term is greater than the second polynomial equation, then copy the coefficient term and exponent term of the first polynomial to the coefficient term and the exponent term of the resultant polynomial and obtain the next term of the first polynomial. Then what we were doing, we were obtaining the next term of the first polynomial, and in this case what we are doing, we are for both. Okay, so we have completed this particular part. Now next is, if the first term exponent part is not greater, that means the second term exponent, if they are not equal and first term exponent part is also not greater, then that means the second polynomial equation is having the highest exponent term. So we will copy the coefficient term and exponent term of second polynomial to the coefficient term and exponent term of the resultant polynomial and will obtain the next term of the second polynomial. We will repeat this step until and unless one of the equation has completed all its term. If any of the polynomial equation is over and other is remaining, then in that case we will be out of this particular loop. We will compare the remaining term from non-empty polynomial. Whichever polynomial equation is remaining, we will copy the remaining terms from that particular non-empty polynomial equation into the resultant polynomial, and we will return the address of the resultant polynomial, address of the first node of the resultant polynomial back to the function whichever has called that particular algorithm. Okay, so this is the polynomial addition algorithm. Same algorithm we have used to implement. We have created a function for adding two polynomial equation. In this, the struct node poly 1 is the address of the first node of the polynomial, and this poly 2 is the address of the first node of the second polynomial equation. This poly is for resultant polynomial equation. Okay, so we have the address for all three. Now we have compared for first we are comparing with both the polynomial equation are existing or not, because if any of one of these is empty, then the resultant will be the other polynomial equation. So if both are existing, then next we are comparing for the exponent part. Okay, so we have compared for exponent. If first polynomial equation exponent power part, exponent means power, so we have compared with the power, is having the highest power as compared to the second. So we will, if the first is having the highest power, we will copy the exponent and coefficient part of the first part as it is in a resultant polynomial equation, and will move to the next term of the first polynomial equation. If this condition is false, then we will be checking for the whether the exponent part of the second polynomial equation is greater than the first. So if this condition is true, then we will copy the exponent and coefficient part of second polynomial equation term to the resultant polynomial equation term, and will move to the next term of the second polynomial equation. And if the exponent part, if the power of both the polynomial is same, exponent part of both the polynomial equation is same, then we will add these coefficient part. Then we will add the coefficient part of both the polynomial equation. We'll copy the exponent part of any of the polynomial equation to that, and we'll move to the next term of both the equation. Okay, now again we will create a node and will follow the same steps. We will be switching to other nodes. Okay, we are repeating these steps till any of the polynomial equation gets over. Now we are out of this loop, means we have completed any one of the polynomial equation. So we will be checking whichever polynomial equation is not empty, means that have a remaining terms. We will copy the remaining term of that particular equation to the resultant polynomial. We have checked whether the list of polynext exists, first linked list exists, first polynomial equation exists, or second exists. Whichever will be existing, we have compared. We have copied the remaining term of that particular polynomial equation in the resultant polynomial equation. Okay, so this was the function for adding two polynomial equation. The assignment for you will be, we have written the function. Now you have to write a program to implement addition of two polynomial equation, and you have to write a program to implement subtraction of two polynomial equation. Okay, these are the two tasks which you have to do. Next will be the multiplication of two polynomial equation. To perform the multiplication of polynomial, what we are doing is we are multiplying the coefficient term of both the polynomial equation and adding the exponent term of the polynomial equation. In the addition part of the polynomial equation, addition of polynomials, we were not performing any operation on the exponent. We were just comparing the value of exponent, and on the basis of the exponent value, we were adding the coefficient, or we were copying the value of coefficient to the resultant polynomial. But in the multiplication of polynomial, we will be multiplying the coefficient term of both the polynomial equation and adding the exponent value. So what we will be doing will be, we will start scanning the equation, and we have started scanning from left to right both the equation. First term for this will be 8x power 4. First term for the second polynomial equation is 3x squared. So what we have done is, we have multiplied the coefficient value 8 into 3, that is 24, and added the exponent value 4 plus 2 is 6, so it will be 6. Now again we have switched to the second term of the first polynomial equation. Now we have again multiplied this particular first coefficient of second polynomial equation with the second term of the first polynomial equation. 3 into 6, 18, and added the exponent value, that is 2 plus 2, 4. Then again we have multiplied the coefficient value 3 into 5, 15, and added the exponent value x cube. Then again we have multiplied the coefficient value 3 into 2, 6, and we have added the exponent value 2x power 0. So 0 plus 2, it's 2x squared. Now once we have multiplied all the terms of the first polynomial equation with the first term of the second polynomial equation, then we will move to the next term of the second polynomial equation. Now again we will be performing the multiplication of coefficient and addition of exponent for the second term of the second polynomial equation with all the terms of the first polynomial equation. Then we will move to the next term of second polynomial equation. The steps will be continued. Okay, once we have completed all these second terms polynomial second terms of the polynomial equation, then what we will be doing with this resultant polynomial equation, we will be comparing the exponent term. If the exponent term of any of the term of the resultant polynomials are same, we will add the coefficient value of that particular term. Like x power 6, there is no x power 6, so this term will be in same as it is in the final resultant equation. Now next is 18x power 4. They have compared for the x power 4. There is one more, that is 16x power 4. We will add the coefficient of both the term and will add in the final resultant equation. Next is 15x power cube. We will check for x power cube. Here it is 6x power cube. Then we will add the coefficient value 15 plus 6, that is 21 x power cube in the final resultant equation. Like this we will be performing the addition of the resultant equation if and only if the exponent value of that particular terms are same. The algorithm for multiplication will be, first we will be checking whether the given two polynomial equation are non-empty, because if any of the one of the polynomial equation is empty, the final result will the multiplication won't be possible. 0 into anything will be 0, so exist. But if the two given polynomial equation are non-empty, then we will be scanning the second polynomial equation from left to right, and for each term of second polynomial equation, all the terms of first polynomial equation is scanned from left to right, and its each term is multiplied by the term of the second polynomial. That is, find the coefficient by multiplying the coefficient of both the terms, and we are finding the exponent by adding the exponent of both the terms. Okay, once we have completed this particular step 3, then if the product term already exists in the resultant polynomial, that means if the coefficient value in the resultant polynomial are same for more than one terms, then we will add its coefficient are added, otherwise a new node is inserted for this product term as a resulting polynomial. Okay, so this is the multiplication, how we perform the multiplication on the polynomials. Okay, so this was the operation on polynomial equation. Thank you.